All right, so in this section, or in this lesson, we're going to talk about operations with radical expressions. And you can see that, or if you can't see now, you will see soon, that this note sheet is from a different, I'm kind of adapting it for this from a different section in the old textbook. And so some of this stuff is good and useful, and some of it's just a kind of a reminder of some things with, like, radicals. For instance, like if you have root 2 times root 8, you can get root 16. That rule applies as long as the numbers under the root are positive. Some things that we've talked about before are kind of in here. What we're going to talk about today is rationalizing denominators and then also doing operations with square roots. And so I've modified this note sheet quite a bit and chopped off a lot of examples because there's quite a few here. So the first one, I just got rid of this example, and I wanted to look at just a simple problem like this. Now, one of the problems with this expression here is that there's a square root in the denominator. Now, it's not a huge deal, especially given that we have modern, like, graphing calculators and modern technology to have a square root in the denominator, but you will still see on standardized tests that, typically the square roots are not left in the denominator. So the way that we have to go about fixing that is a process called rationalization. And to rationalize the denominator, if it's just one thing, the square root of one thing in the denominator, we're going to take and multiply the top and the bottom by that one thing. So we'll multiply the top and the bottom by square root of 7 in this case. And by doing that, on the bottom, I'm going to get square root of 7 times square root of 7, which is square root of 49. The square root of 49 is 7. So on the denominator, I get 7. On top, I get 9 times square root of 7. There's nothing we can do with that. That just stays as it is. And then that's our simplified form. Now, this looks more complicated, but we've gotten rid of the square root in the denominator. So then let's go on to the next one here. Oh, quick note on this. Do not take and simplify these 7s out here. This 7 under the square root has to stay there. It's not going to simplify with the square root or with the 7 in the denominator. All right, so another situation here. This is the square root of 6 over 5x. Now, this one doesn't look bad. It doesn't look like there's a square root in the denominator, but the square root of a fraction can be rewritten like this. Square root of 6 times the square root of 5x. And by the way, I changed this to just a square root. I think it was a 4th root before. So to rationalize this, I'm going to multiply the top and the bottom by square root of 5x. That's a 6. Try again, Zach. There we go, 5x-ish, I guess. And then the square root of 5x. On the top, I'm going to get square root of 6 times square root of 5x. That's square root of 30. X. The denominator, I'm going to get square root of 5x times square root of 5x. That's just going to be 25x squared. The square root of 25x squared. That'll be just 5x. Okay, and that's it. That's as simple as this gets. Again, if you're going to be inclined to simplify the x's, you can't. This x is underneath the square root. It's kind of locked in there, right? So that's it for that one. We're going to the back page now. Not going to do those two examples at the bottom. And I've changed this problem. This problem I'd like to just do 2 square root of 32, just remind you of how to simplify something like the square root of 32. The process that I taught is you take 32, put it up in the little, what do I call it, the radical reduction machine or something like that. You put 32 up there, and you ask yourself, what's a small prime number that goes into 32? Well, 2 is the most obvious one. Then you take 32 and divide it by 2, and you get 16. You ask yourself the same thing. You can take a 2 out. 16 divided by 2 is 8. Same question. Small prime number that goes into 8. 2 again. 8 divided by 2 is 4. 2 again. 4 divided by 2 is 2. 2 again. 2 divided by 2 is 1. When you get to 1, you're done. Since we're taking the square root, we're looking for pairs of numbers. So there's 1, 2 pairs of 2's. So let's be very careful about what, where these 2's go. So this 2 out in front, right here, I'll write in black. That has not changed. That's still the 2 out in front. These 2's right here, that one pair of 2's and that other pair of 2's, that's going to come out in front. 2 times 2. Each one of those comes out in front. And then this thing left over, this 2 left over, that stays underneath the root because there's not a complete pair there. So we've just got the square root of 2. So our final answer for this one is going to be 2 times 2 times 2, which is 8. square root of 2. Okay? So that's how that radical reducing process worked. The new concept here is going to be exemplified by this next example, which is 5 root 12 plus 2 root 27 minus root 128. We're going to go ahead and simplify that. So to simplify this, we need to break down each root. So we'll take 12 first, put that in the radical reduction machine, and so we can take a 2 out, we'll get 6, take a 2 out again, we'll get 3, take a 3 out, 3 divided by 3 is 1, 1 you're done. So let's reduce everything, and then we'll come back and see where we're at as far as simplifying the entire expression goes. All right, then we're going to take 27 and simplify that. So 27, we can take a 3 out, we get 9, a 3 out, we get 9, divided by 3 is 3. Take out 3 out again, we hit 1, you're done. And then 128. Now, at some point, you start to recognize the powers of 2. 128 is a power of 2, and it turns out to be 2 to the 7th. Okay? So I'm just going to write that as 2 to the 7th, and then we'll think about how to simplify that in a second. All right, so first expression, 5 root 12. Well, 12 breaks down into 2 square root of 3. So I have 5 times 2 times the square root of 3. Okay, one pair of 2's comes out in front, 3 is left over underneath the root. Plus 2 times square root of 27, so that's one pair of 3's comes out, square root of 3 left over underneath. Okay, the 128 then, the square root of 128, well this is 2 to the 7th, and we want to take pairs of 2's out of that, so we'd be able to get 3 pairs of 2's. In other words, we'd have 2 squared times 2 squared times 2 squared, and then there'd be a 2 to the 1 power. This would be left underneath. These would be my pairs of 2's that I'd be circling. Okay. So that leaves me with minus 2 to the 3rd for the 3 pairs of 2's times the square root of 2. Things just sort of jammed together here, but we end up with 10 square root of 3, 6 square root of 3, and then 2 to the 3rd is 8, so minus 8 square root of 2. 10 root 3 plus 16 root 3, those are like terms. It ends up being 16 square roots of 3 minus 8 root 2. And that's how you simplify that one. All right, let's talk about multiplying radicals now. Here I've got 4 root 3 plus 5 root 2, and I want to multiply that by 3 root 2 times, or minus 6. And so I'm going to use the box method, especially with roots. The box method is your friend. Because things can get sort of complicated sort of quickly. So we'll sketch out a little 2x2 box here. We've got 4 root 3, 5 root 2, 4 root 3, 5 root 2, and then we have 3 root 2, negative 6. Then we're going to multiply rows by columns. So I'm going to have 3 root 2 times 4 root 3, that's going to be 12 root 6. I'm going to have 3 times 5, that's 15. Root 2 times root 2, that's the square root of 4. Square root of 4 is just 2, so that's just 15 times 2. Here I'm going to have negative 6 times 4, that's negative 24, square root of 3. And then over here, in the last one, I'm going to have negative 6 times 5, that's negative 30, and then square root of 2. Okay. This expression here, this will end up being just 30. And then none of this other stuff is going to simplify. So, and since I'll run out of space if I try and write it right here, I'm just going to write the answer below. But my answer then is going to be 12 root 6 plus 30 minus 24 root 3 minus 3 root 2. And that's it for that one. Okay, the last type of example we are going to look at is called rationalizing the denominator, and it's in situations when we need, it's more complicated than just having the square root of one number in the denominator. Okay, so you can see here, I don't just have square root of 5 in the denominator, I have square root of 5 minus 1. So to solve this problem, what we're going to do is multiply by something called the conjugate. So the conjugate is just whatever the expression is in the denominator with the sign changed in the middle. Okay, so this one, the conjugate would be multiplying by the square root of 5 plus 1 over the square root of 5 plus 1, like this. Okay, so on top, this isn't too bad. There's nothing really weird here. We just have 2 times the square root of 5 plus 1, so it'd be 2 root 5 times 2, or plus 2 times 1. So 2 root 5 plus 2 divided by, and now this, we've got to be sort of careful here. So we've got root 5 minus 1, root 5 plus 1. I'm going to put that in a box and I'm going to multiply it out. So I have root 5 plus 1, and I have root 5 minus 1. So I'm going to multiply root 5 times root 5. That's the square root of 25. That's just 5. 1 times root 5 is root 5. Negative 1 times root 5 is negative root 5. And then negative 1 times 1, that's negative 1. Now, this is the kind of the beauty of this method is that when you combine like terms, you have negative root 5 plus root 5. Those add to 0. So then you end up with 5 plus a negative 1. That's just 4. I guess I can write that out. So 5 plus a negative 1, or 5 minus 1, that's just 4. So you end up with 2 root 5 plus 2 over 4. And we've gotten rid of the square root in the denominator. We should probably do one more of those. You see this one, we have the square root, we have 2 square roots. So we're going to multiply by the conjugate, which is going to be root 3 plus 2 root 7. And then this one will be root 3 plus 2 root 7. It'll be the same thing. On top, you're going to end up with negative 3 times all of that. So it's negative 3 root 3 minus 6 root 7. On the bottom, we're going to need to multiply this out. We're going to use the box method again here. So we have root 3 minus 2 root 7, and we have root 3 plus 2 root 7. All right, so root 3 times root 3 is just 3. Root 3 times negative 2 root 7, that's negative square root of 21. Root 3 times 2 root 7, that's 2 square root of 21. Nope, sorry, shoot, that should be negative 2, sorry. Negative 2. And then the last one here is going to be negative 2 times negative 2, that's negative 4. Root 7 times root 7 is root 7, or so just 7. So this will end up being negative 4 times 7. These are opposites, so when you add them, they go away. So on the bottom, you'll have 3 minus 28. So 3 minus 28. So your final answer will be negative 3 root 3 minus 6 root 7 divided by negative 25. All right. And that's it for this section. There's a lot in there, just kind of nitpicky stuff, so it might be worth sort of scrubbing through this again if you're confused on any part of it. But otherwise, that's it for operations with radical expressions.